So in this video, we're going to specifically look at the surface area of cylinders. Now, the hint when you're working out surface area is to always think about what would the net of that shape look like if you unfolded it. So the surface area of a cylinder is made up of two circles for the top and the bottom. So imagine if you're taking the top off of a tin of soup, you're left with a circle. And if you were to take the label off of a tin of soup, it would end up being a rectangle. So the top and the bottom are the area of two identical circles because a cylinder is a type of prism, so it has the same cross-sectional area at every single point along the height of the cylinder. And we work out the area of that flat surface by pi r squared. And then we've got the curved surface, which is the area of one rectangle. Now, we need to work out the dimensions of our rectangle. So if you think about that length of our rectangle, it's going to be the same as the circumference of our circle. So we're saying that the length of our going to be equal to the circumference, which is the same as pi times the diameter. And our other dimension is going to be the height of our shape. And so we can say that the curved surface formula is pi dh. So let's have a look at an example. We want to calculate the curved surface area of this cylinder. So in the first part of this example, it's only asking for the curved surface area. So we're only interested in that rectangle. We're not interested in the top and the bottom at the moment. Now we know that the height of our curved surface is 12 centimeters. And we also know that the length of our rectangle is going to be pi d because it's the same as the circumference of our circle. And so it's going to be pi multiplied by 10, and we're going to leave that as an exact value because the question hasn't asked us to do any rounding. So in order to work out the area of that rectangle, we're going to take our pi d, which is 10 pi, and we're going to multiply it by the height, which is 12. And that's going to give us a value of 120 pi centimeters, and they're squared centimeters because it's area. Now, the next part says hence, which means let's use what we've just calculated, calculate the total surface area, and now we're going to have to round to the nearest squared centimeter. But from the previous example, the curved surface area is 120 pi squared centimeters. So the only bits I need to work out now are my two circles. So I know I've got two circles. I know that the area, and I'm going to call it area of the flat surface, is pi r squared. Now on my original diagram, I've been given the diameter of 10. So I know that the radius is going to be 5 centimeters on my sketch. So it's going to be pi times 5 squared. And we're going to write that as 25 pi squared centimeters. So the total area, so area total is going to be our curved surface, which was 120 pi, plus the top and the bottom. So we're adding our 25 pi on twice, and that's giving us an exact value of 170 pi. Then the question is asking us to round to the nearest centimeter squared. So 170 pi is 534.07, etc. And so if we're rounding to the nearest squared centimeter, it's 534 squared centimeters.